Hi guys, Mrs. Valdivia. So I'm going to give you guys a pre-lab lecture. Uh, your lab flow number 4 is on chemical and physical changes and properties, and it's probably one of the easiest labs you're going to do. So let's get on to it. So chemical and physical changes, what are they, right? What do they even mean? We actually see this in our everyday life, but we just don't describe it because we don't take the time to describe the process of what's happening in nature. And you're going to notice these changes as we do our lab. Okay. So pure substances have a unique set of chemical and physical properties, right? So if it's pure, it's a very unique to itself. You could tell what something is most of the time by just looking at it. Okay. Physical properties. So physical properties can be measured or observed without changing the identity of the substance. Okay, so one more time, you can measure it, you can look at it, right? But you don't change what it actually is. Okay, the chemical makeup is not changing when the properties are observed. So what does that mean if we're not changing those chemical makeup? Well, if you look at the image on the background, you have a piece of ice, right? And at the bottom of the ice, what do you see? Water. The ice has melted. So this is a physical change in which you have a solid that has melted into a liquid. And you could get another change, right? The liquid could evaporate into a gas. So water is one of those examples of something we see in its solid state, its liquid state, and its gas state almost every single day. The perspiration in a window, right? That's a physical change. That is vapor condensing, right? So that is your H2O gas turning into H2O liquid, just the condensation alone. Okay. So examples of things that constitute physical properties, okay? So the color something is, you can describe it and say, oh, this is pale yellow. This is a shiny metallic color, or it is a dull metallic color. Okay. Odor, what does it smell like? Does it smell sulfuric? Does it smell like lemon? Roses, is it an almondy smell? Be careful, could be cyanide. What is its melting point? Does it always melt at 80 degrees no matter what? Freezing point, density, mass, the hardness of something. Okay, so these are all examples of physical properties. Now we're going to go into chemical properties, something just slightly different, Chemical properties indicate how a substance reacts with other substances. So what is going to happen, basically? You can only know it's going to be a chemical change when it's actually going through a chemical change. Now, because we've collected data for such a long time, we know which elements will produce chemical changes when combined together. Most of our reactions are chemical changes. Okay, so properties of something that exhibits chemical changes is its flammability, right? Is it highly flammable? Does it have a low flammability? Is it combustible? Is it going to explode? It's burnable. It reacts with this, right? Baking soda and vinegar. That's a chemical reaction. All right, so let's go into a couple more examples. Going back to our water example, physical versus chemical properties of water. Okay, so let's note a couple things that we know about water. One thing, you're gonna have water, right? I could kind of see through this water, so does it have a color? No, it's colorless. Does it smell like anything? No, water doesn't really have a smell, so it's odorless. Right now, is it a solid, liquid, or gas state? Okay. Well, to me, it's moving around in the cup. It's definitely not a solid, and it's not a gas state, so there's no vapor cloud. So it's in a liquid, right? and liquid at room temperature. Okay. What does it taste like? Well, tasteless, I guess, but at the same time, tastes like water because water is tasteless. Right? Uh, don't ever taste anything inside your chemical lab. All right, one more time. Don't ever taste anything inside your chemical lab. Don't eat in your lab and don't drink in your lab. Step outside of your lab and put a snack in your mouth if you need to, or drink your coffee outside. So there's always a section outside by the doors of the labs to put your stuff down. If not, pick a corner and put it down there. Do not bring it into the lab. It's such a health hazard, and sometimes we don't pay attention to that. We think it's harmless. It's harmless. It's not harmless. Don't get comfortable. Respect your chemicals. Okay, now on another note, going back to water, what's the freezing point of water? Well, water freezes at 0 degrees Celsius, or what would that be? 32 degrees Fahrenheit. What does water boil at? Okay, so when you start boiling water, it's going to boil at 100 degrees Celsius. Okay, water is very flowy, right? So if I were to grab my water and, okay, it flows. So there's another physical property of water that we can describe. Now, what are some of the chemical properties of water? Okay, what do we know about water chemically? Well, let's go back to that baking soda and vinegar. What about baking soda and water? We usually get some fizz, right? What else gives us fizz? Okay, so you know those little packets of Alka-Seltzer, right? Throw them in water, you get fizz. Okay, so those are made with some sort of like baking soda, magnesium, I'm not quite sure what, some citric acid probably. Speaking of citric acid, that means water must react with acid, right? So it reacts with like your hydrochloric acid, it's going to react with acetic acid, different ones. Something else we know about water is that it does not react with oil, okay? So if you try to mix water and oil together, it's not gonna happen. And lastly, physical, oh sorry, we had one more, I skipped it. It's not flammable. You can't catch water, pure water, on fire. There could be something on top of it, right? Like crude oil, and you can catch the crude oil on fire, but not the water. So going into some physical changes. Okay. Oh, give me one quick second. Baking some bread and yeah, I had to take it out of where it was at. Okay, so physical changes. Uh, changes in appearance without changing the composition of something, right? Like solid turning into water is a physical change. Taking a piece of wood and cutting it in half is a physical change. Um, breaking glass is a physical change. Taking a cookie and pulverizing it, right? Turning it into dust, physical change. Breaking concrete, same thing, physical changes, right? A lot of like sharpening a pencil, those kind of things, still a physical change, even though it looks different. It's a much smaller in size. It doesn't matter what the size of it is going to be, the volume of it. Um, it's a physical change. You're still going to have the same thing no matter what. Take an apple and peel an apple, it's still an apple, right? You take the apple and you cut it into tiny little pieces, it's still an apple. But the moment you bake your apple in something else, you actually start changing the composition inside of the apple because you're baking it, right? So you're starting to produce a whole bunch of other chemicals inside of it. That baking it or cooking it would be a chemical change. Cutting it and nothing else is a physical change. We talked about this one: melting, freezing, boiling, subliming, going from solid to gas. Chemical changes and its reactions, right? So in this one, when you have one more substance reacting to form a new substance with different chemical and physical properties. So the beginning of a substance is different from the ending substance, right? An apple, bite it into it, delicious. You bake it, oh, even better. It releases all the sugars from it, okay? So raw apple versus baked apple, chemical change happened right there, right? It's different at the end. It's still an apple, but it tastes different. An egg, a raw egg versus a cooked egg, that's a chemical change. So breaking an egg into a bowl, physical change. You took it out of its container. It's no longer in that little oval shape, right? It's now in a bowl kind of floating around. Then you cook it, chemical change. Now, in actual chemical reactions, you're going to notice chemical changes because there's going to be small solids that get produced inside of it. You're going to call it something cloudy. The actual word is precipitate. So you would say a precipitate formed. And a precipitate is just basically solid little particles. Sometimes they're so small, it just looks cloudy. But it's particles that have formed or some sort of solid inside of your mixture. You're going to have a color change, and that color change is not related to food dye, right? If it's just food dye, you didn't really do much of a chemical change. So it has to be, you put two clear liquids together and boom, it turned yellow. Chemical change. You smell something, it went from odorless to like, oh dear Lord, what is that, right? Or that smells nice, right? If you get a change in smell, if you touch the container and all of a sudden it's super hot, right? You have an exothermic reaction. Or it's super cold, meaning you have an endothermic reaction. That is also a chemical change. Okay. So lastly, all chemical reactions can be described by a chemical equation, meaning reactants produce products. We already know based on our previous lectures that the little arrow means yields. Okay, so let's go ahead and read this equation right here. Iron plus oxygen produce iron 3 oxide. How do we even write that? Well, you have to go to your periodic table. You're going to find iron and you're going to put the symbol down. Same thing with oxygen. You're going to put the symbol down. And then we're going to have to combine them together to form iron 3 oxide. Okay? And when you combine them together, you have to make sure that their charges equal 0. Okay, their oxidation states. And we're going to get further into that in our upcoming chapter. So this right here is your word equation, and this one is your formula equation. So word equation, formula equation. You have to make sure things are balanced. If you look at this equation, I could already tell you that it is not balanced. So we're going to go ahead and balance it. I have 2 irons here, but only 1 here. So I'm going to add 2 as my coefficient. So now I have 2 irons, 2 irons. I have 2 oxygens and 3 oxygens. What? How do I even do that? How does that even work? Oh my gosh. No, just kidding. Hey, but that's how most of you guys react. Quite simple, multiply them together, right? They're in their lowest states possible. 2 times 3 is 6. So you want to make sure their totals are 6. So you're going to multiply 2 by 3 to get 6. You're going to multiply this 3 by 2 to get 6. So now we have 6 oxygens because we have 2 times 3. However, what just happened? Using that distributive property, we also multiply the 2 by 2, so we have 4 irons. Quite simple, just turn this 2 into a 4, and voila, your equation is now balanced. Law of conservation of mass, we covered it also in the last chapter, but let's recap. It's any chemical or physical change, matter cannot be created nor destroyed. That's what led to us balancing the previous equation. So the mass of your reactants must equal the mass of your products. So hydrogen plus oxygen gives us water is the example we've been using. And in this case, let's say I have 10 grams of hydrogen and 5 grams of oxygen. I'm going to produce 15 grams of water. How? All I'm doing is adding these quantities together to get the total from my product. Okay. Now let's go ahead and write this in formula notation. Hydrogen plus oxygen gives me water, H2O. All right, now we learned a couple things as well previously. Hydrogen and oxygen are both diatomic, which means they come in twos. All right, so they come in twos when they're by themselves, right? Then they break up and everything like that and pair up with other things, so they're no longer in twos. It's like twins growing up together and then they separate, right? That's what these are. Okay, so we're gonna go ahead and balance. I have 2 oxygens, but only 1, so that means I have to multiply the entire molecule of water by 2 to get 2 oxygens. And I have to multiply my hydrogen as well, and that gives me 4 hydrogens. So I'm going to write this down so that we could clearly see it. I have 4 hydrogens, and I have 2 oxygens here. I have 2 oxygens, so that's good. That means I'm just going to put a number 1 right there as my coefficient. I have 4 hydrogens, and I have 2 here, so I'm going to put a number 2 there as my coefficient. So now I have a total of 4 hydrogens and 2 oxygens. I know it looks like a 20, so I'm going to put an OX just so you guys could tell that it's oxygen and not a 20. Or better yet, I'll do this. Okay. All right, you guys, so that ends this little section, your pre-lab for the chemical and physical properties. Please enjoy it. Make sure that you write down all of your observations. If it's water, don't just put it's a colorless, clear liquid. Look at all the physical properties we were able to describe on water alone. So be detailed and enjoy. Ciao.